Welcome to homework.
We have a pretty simple case. We have what's being defined as a penetration distance, eta, and it's defined as a distance in which the wave function decreases by a factor of 1 over e. And so the application would be some particle hitting some step potential, some finite step potential with some height u naught. It's coming at it with some kinetic energy. And so it would penetrate into this potential bump, and its wave function would rapidly decay by some exponential factor. And this allows us to define this penetration depth, stopping distance. And we are actually given a closed form expression for eta. So this ends up being relatively straightforward. All we have to do is plug in some numbers and get a result. So we have for part A, we find eta for an electron with kinetic energy 13 electron volts and a mu naught potential height of 20 electron volts, and then do the same thing for a proton with 20 MeV and u naught of 30 MeV. So we can show the calculation once for the electron. I think the proton will be essentially the same. So we plug a Planck's constant up here, or reduced Planck's constant rather. It's all over big square root. We use the electron mass of 9.1 times 10 to the negative 31 kilograms. And then the difference, it's 20 EV minus 13 EV, gives us 7. So we just plug this into a calculator. We get a result of 7.4 times, that's a 7.4 times 10 to the negative 11 meters. So maybe 1/100th of a nanometer. So a very, very small penetration distance. If we do the same thing so this is for an electron. If we do the same thing for a proton, we'd plug in similar numbers. The only thing that's changing is the denominator. We would end up with 1.44 times 10 to the negative 15 meters. So the penetration distance for something much more massive, like a proton, is going to be much, much smaller. And the reason is because the mass appears in the denominator, and obviously the mass of a proton is much, much higher than an electron. So that would explain it. And that's really everything there is to this problem.